Right, good morning. Hope you're having a good half term. I'm obviously having a brilliant half term because I spent the time marking your KA, and then now I'm going to go through it for you. So multiple choice, but the easiest way to make sure that you get these answers right is to scribble a Hess cycle if you get a multiple choice, really, because a lot of you got this with the wrong sign. If you'd drawn the Hess cycle and quickly just done the calculation, you would have seen it was minus 42. Okay, so you've got the equation up here, but it's an equilibrium, but it is being asked you are being asked for reacting species, enthalpy change for the reaction of carbon monoxide and steam. So obviously your arrow is going in that direction. And then when you draw it out, you can see how the calculation is done and you get the right sign. Same with this one, really. You're given no, you're not actually, sorry. You're given the values for the formation of these different. You've got carbon dioxide, water, and butane. Yeah, you've got enthalpy change of formation. So again, scribble out your cycle, but you need to recognise that that's what you've got here. It's not given to you in a table. Here it is in a nice easy table. It's enthalpy change of combustion data. So we need combustion products. We're being asked for enthalpy change of formation of this. So it's your unknown. Again, very simple if you get the table the right way round. And then the final multiple choice question. Again, you're being asked for enthalpy change of formation of carbon monoxide. So you're given an equation up here, but you're given an equation where it's got 2 moles of carbon monoxide. So you are going to need to find the value that you find from the data you're given here will be 2 moles of carbon dioxide. So you're going to have to divide your answer by 2. Again, this is, it's just kind of slightly different in that you're given the enthalpy change of the reaction. Yeah, and you're being asked to find like one of the products here. So you have to put your unknown on the side of the triangle or on the side of the Hess cycle that it refers to. Okay, let's have a look at that. Make sure you understand what I've done. Question 5. Write an equation for the decomposition of hydrazine, and you're given the formula into ammonia and nitrogen. Now, if you don't know that ammonia, the formula is NH3, you're not going to get this right, but you should know the formula for ammonia. That's one of the common formulae that you should know off by heart. And when you write nitrogen in an equation, you always write it as N2 in the same way as you do any other gas on the periodic table, apart from the noble gases. Oxygen, nitrogen, chlorine, fluorine, they're all N2, F2, Cl2. They're diatomic, yeah? You don't write 2N, so you would not get the mark for that. But learn your common formula, please. Again, this is a learning thing. Learn your definition. 2 marks, for that definition. This confused some of you, and I'm not quite sure why. If you see a question with mean bond enthalpies in a table, or mean bond enthalpies given to you, it's the very straightforward calculation of reactants minus products. Now, obviously, they've even marked out the bonds for you here, so you didn't even have to write out the molecules. The most common mistake, and I said this in class, is that you miss a bond. So make sure when you write it out, you are absolutely clear which bonds you've included. A lot of you missed that NN bond, the 163. And obviously, if you miss a bond, you can't get the right answer. But you did get a mark if you recognised it was reactants minus products. Okay, again, 2 definitions. There's nothing really to say, just learn them, please. This is some of you got confused here or trying to write your own Hess cycle, but the Hess cycle is already drawn for you with the arrows. Yeah, so basically you had to recognise the 2 routes. This arrow follows this arrow, and this arrow follows this arrow, so they're your two routes. And then you just have to identify where these values go on those arrows, and then you write your equation. Okay, and we're looking for enthalpy change of formation of these H plus and Cl minus in solution. That's enthalpy change of solution, really. Okay, not difficult, as long as you again practice those Hess cycles and those arrows and make sure you're clear what they're telling you. Okay, standard enthalpy change of formation data here. Look, yeah, it tells you even in the question. Why don't we form elements? You know, why don't we have a value for the enthalpy change of formation of carbon, nitrogen, or any other element? Because we don't form them. They are already formed. Okay, it's telling you to use that data to calculate for the enthalpy change for this reaction. So we're looking for this value. Pretty straightforward. It's formation data. You've got elements at the bottom, arrows going up, etc. Okay, question 8. This one, where are we? Yeah. Looking for Q equals MC delta T. The most important thing here, recognise it wants it to 3 significant figures. This is not a difficult calculation, but you lost a mark if you didn't give it to 3 significant figures. So if you got 38.31, you actually had the right answer, but you only got 3 marks. I've just realised when I've looked at the mark scheme that actually it does say that some of you had added the mass of your sodium carbonate to the mass of the acid, 50 grams of acid. It does say that you could use that mass. So if I've marked that incorrect, then you can give yourself those marks. I've only just realised that. But I would have, I mean, the answer that they wanted was the using 50 grams of the acid as the mass of the surroundings here. Okay, but I'm not sure that all mark schemes would allow that, so you know, got to be a bit careful. Okay, then you're given this great long equation in part B, aluminium, ammonium chlorate, etc., and you're given an enthalpy change value delta H, and then we're given enthalpy change of formation data for each substance on here. Okay, apart from the element, of course. So standard enthalpy change of formation definition again. Some of you forgot to give the standard condition, so you lost a mark for that. So really irritating for you. Write the equation including state symbols, which some of you forgot, for the reaction that represents the enthalpy change of formation of ammonium chlorate. Some of you are putting aluminium in here. I have no idea. You know, think about the definition of standard enthalpy change of formation. So you start with this. This is what you're forming as a solid, and then basically every element that makes it up, it's from its the definition is from its constituent elements. But again, you need to remember that you write these gases as diatomic. So it has to be half N2, half Cl2, not just N, not just Cl. So some of you missed marks for that. And then the enthalpy change of formation of NO, which is in your original equation. You had to go back to this equation, yeah? So remember that. So I rewrote the equation so that I could actually see what I was doing. Use the data from the table, because you're given enthalpy change there of the reaction, yeah? But you're being asked for NO, and so this is three times enthalpy change of formation, because there are 3 moles of NO. But as long as you remember that, and then you've got your Hess cycle the right way around, because it's formation data. Write your calculation out, rearrange it for X, and there you go, plus 90. Question 9. Okay, again another definition. Obviously you wouldn't get all of these definitions in an exam, maybe 1 or 2. An equation for the complete combustion of ethane, so you need to be able to do that. Very straightforward. when you're combusting a hydrocarbon, you balance the carbons, you balance the hydrogens, and then you go back and balance the oxygen. And as you can see, I didn't leave enough room to write in my 3.5, but in a sense it doesn't actually matter here because we're given enthalpy of formation data and there isn't a value for oxygen, but it needs to be in our equation obviously to make sure we recognise everything else is correct. And that's it really. I mean, draw your cycle, do the calculation. This last one was obviously a little bit harder than something that you've seen before because you've always done the straightforward Q equals mc delta T calculation. But here you're given the total heat capacity, which is basically M times C. Yeah. And you're told that you've got 0.1 grams of methane and you're given the standard enthalpy of combustion of methane, which of course relates to 1 mole of methane. So basically you find your number of moles of methane from your 0.1 grams and then that value minus 890 relates to 1 mole. So if you multiply it by the number of moles you've got, that'll tell you how much energy was actually evolved. Yeah. You need to convert that back to joules and then it will equal Q because Q is in joules whereas this is in kilojoules. Okay. So then you rearrange Q equals mc delta T because you're looking for delta T. So you've got Q, mc is given to you in the question and that's it. But I do understand that some of you got confused with that question because it was asking you to really understand and apply your knowledge there. So you really had to think hard. Okay, so well done to those of you who did get that right. Okay, good. I'll see you all when we get back. Bye for now.